platform, that is Gradeup, my friends. So, my dear friends, today we will discuss about the arches and cables, the problem which are based on arches and cables. So again, this particular topic is very important for your gate examination. Sometime they may ask the question from arches or cable also, right? In the last few years, my dear friends, what we have seen that the cable is also important for your structure analysis. And this time, you know that, my dear friends, the gate will be conducted by IIT Mumbai, and maybe possible you may get the question from these type of topic. Okay, so let me introduce myself. My name is Krishna Yadav, my dear friends, and I had 8-year teaching experience in this particular field. And I done my masters from IIT Roorkee. I mentored almost 14,000 plus students, and these are my area of expertise. So guys, we will discuss the question in the detail, my dear friends, and we'll try to solve the problem in shortest duration also. Okay, so my dear friends, tell me whether I'm perfectly audible as well as visible to all of you or not. Just quickly tell me, guys, my dear friends. Just tell me. Good evening, Sonu. How are you? Asim, good evening. Okay, guys. So I think I'm perfectly audible as well as visible to all of you. So this is the first question, my dear friends, which we have to solve. And you can see here, my dear friends, what we have to do. We have to just find the equation. We have to just find the equation of cable profile. So find the below cable suspended through simply supported. Assume A as a point of origin. We have to consider this particular point as an origin. Just we have to find the equation of cable profile. Now, my dear friends, in this particular question, they do not mention any type of loading over there, right? It is generally the shape of cable. This is nothing else. This is the general shape of cable. Now, my dear friends, whenever the question is to be like this one, my dear friends, so just consider it is a parabolic shape. It is a parabolic shape. Now, what is the equation of parabola? You know that, my dear friends, y is equal to 4hx divided by L square into L minus x. Okay, Anshu, audible, sir. Okay, Krishnakant, hi, hello, how are you? Julie, good evening. Audible, ठीक है. Sonu says sir D होगा. Okay, so my dear friends, y is equal to 4hx upon L square into L minus x. This is the basic equation of your parabolic shape. So let me tell you, my dear friends, this is our parabolic shape, and this parabolic shape have a dip of central dip. This is nothing as, this is your central dip, which is h. This one is h, which is central dip. Guys, this one is central dip, right? And this one is span, which is L. Now, my dear friends, whatever distance are there in the x direction or y direction, you have to consider with the origin. Okay, sir. So this is L, and which is given as span. Okay, sir. Now, my dear friends, in this particular case, they have mentioned yc is equal to 5 meter. So you can replace this yc is equal to h. Okay. Now let's put all the values in this particular equation, right? So can I write it? Y is equal to how much? Y is nothing as the dip of cable at any distance of x, right? Y is nothing as dip of cable at any distance of x from the origin, right? So 4 into h. H is equal to how much, sir? It is 5 meter. Multiply by x, multiply by L. L is equal to 30 meter minus x divided by 20 square. Okay, sir. Just solve it, guys. What we will get? 4 into 5. 4 into 5. Wait a minute. It is 30 square. Sorry. Not 20. Let me correct it. It is 30 here. 30 square. Now just calculate it, guys. What we will get? Let us check it. We will get x into 30 minus x divided by how much? 45. So my dear friends, what will be the correct answer? 30 minus x, and it is D. D is the correct answer. D is the correct answer. Yes, Anshu, Anusha, sorry, and Sonu. Yes, you are correct. D is the correct answer. Next question in front of you, guys. Next question. It is based on your three-hinge parabolic arch. Now, as per the question, a symmetrical parabolic three-hinge arch of span 8 meter and central rise is given to us as 4 meter, my dear friends, has got a concentrated load of 10 kilonewton at a location P. Okay, sir. So let's draw a parabolic arch over here, which is to be like this, right? And it's to be 3-hinge arch, 3-hinge parabolic arch. Okay, sir. Now this is our span, my dear friends, which is L, and this one is our central rise. Now this one is rise. In cable it is dip, and in this it is rise. Okay. Now my dear friends, our central rise is equal to h, and h is equal to how much, sir? 4 meter. Now this is the span, my dear friends, which is L. L is equal to how much? 8 meter. Okay. Now a load is present at point P. A load is present at point P, which is present at a distance of 2, 3. We can say that, my dear friends, x is equal to how much, sir? It is 2 meter, and y is equal to how much, sir? 3 meter. My dear friends, what they have considered left support as a origin, right? They have considered left support as a origin, which is nothing as 0, 0, right? And this is nothing as, this is your origin. Now what we have to find? We have to find the bending moment at point P. We have to find the bending moment at point P. So how we can find it? It is very, very simple, my dear friends. Very, very simple. Okay, now. Now, just calculate the reaction first, my dear friends. Let us suppose this is your A point and this is your B point. So can I write it, my dear friends? This one is VA and this one is HA. Yes, sir. And this one is VB and this one is HB. Okay, sir. Just calculate the value, my dear friends. You know the value of P, it is 10 kilonewton. So, my dear friends, can I write it? This is A, this is A, this is B. So, let us consider this point as C. Isko C मान लेते हैं यार, कोई दिक्कत नहीं है. Okay. So, my dear friends, can I write it? Summation moment at B is equal to how much? 0. सोनू कह रहे हैं सर D होगा. Anshu D होगा. Okay, we will check it. Summation moment at B is equal to 0. So, can I write it, my dear friends? VA into how much? 8 minus P into this one, this particular distance, which is equal to how much? Sir, 8 minus 2, it is equal to 6 meter. Okay, so P into 6 is equal to 0, right? So VA is equal to how much? It is 6P by 8. So my dear friends, what is the value of P over here? Sir, it is 10, right? So just calculate it, guys. 6 into 10 divided by 8. So we are getting a value of 7.5 kilonewton. This is the value of VA, right? So can I say that, my dear friends, what is the value of VB? It is summation Fy is equal to 0. VA plus VB is equal to how much? Sir, it is 10. So we know that, my dear friends, what is the value of VA? It is 7.5. Just calculate the value of VB. It is equal to 2.5 kilonewton, right? Okay, sir. Now, my dear friends, we have to calculate the value of HA. Instead of finding HA, my dear friends, just find the value of HB. And you know that if you put summation Fx is equal to 0, then definitely whatever value of HB is there, and it is equal to how much? HA. So just try to solve HB first. Do not try to solve HA, my dear friends. Why it is so? Because you know that if you put MC is equal to 0, so you have to take the consideration of P also in that particular equation. Okay. So my dear friends, let's use MC is equal to how much? 0. So can I write it? It is minus of VB into how much? 4. This is anti-clockwise in direction. VB into 4 anti-clockwise direction, and HB into 4 which is in clockwise direction. So plus HB into 4, it is in clockwise direction. Can I say that VB is equal to how much? Sir, it is equal to HB, and it is equal to how much? Sir, 2.5 kilonewton. Simple. So can I say that, my dear friends, if you use summation Fx is equal to 0, so HA minus HB is equal to how much? 0. Simple. So can I say that HA is equal to how much? HB, and it is equal to how much, my dear friends? 2.5 kilonewton, right? Now, my dear friends, what is the bending moment at P? Just calculate it. You know the value of HA, you know the value of VA. So let me calculate it, my dear friends. फटाफट calculate कर लेता है. Okay, sir. So can I write it, my dear friends? Bending moment at P is equal to plus VA into 2 minus HA into 3, right? VA is equal to how much, sir? It is 7.5 multiplied by 2. What is the value of HA? It is 2.5 multiplied by 3. Just solve it, guys. You will get the answer. 7.5 multiplied by 2 minus 2.5 multiplied by 3. So we are getting a value of 7.5 kilonewton meter, and C is the correct answer. C is the correct answer. कौन दे रहा था D भाई? C is the correct answer. C is the correct answer. Understood? Now this is a very simple question. This is a very simple question. Now let's move to the next question, my dear friends, which is based on your cable. So what we have to do over here? We have to find the ratio of greatest tension to the least tension value. Okay, listen carefully, my dear friends. A cable carrying a load of 10 kilonewton per meter run of horizontal span is stretched between the supports of 100 meter apart. Let us suppose this is a cable which is to be like this, right? And a UDL is to be placed over the span of cable whose intensity is 10 kilonewton per meter. Okay, sir. And it is supported at the same level. It means you have supported this particular cable by a hinge as well as hinge over here. Now, my dear friends, you know that let us suppose this particular support is A, this support is B. And my dear friends, the vertical reaction is VA over here and HA over here. Similarly, VB over here and this one is HB over here. Okay, sir. Now the central depth which is given to us as 8 meter. It is given to us as a central depth 8 meter. Now my dear friends, where you will get the maximum tension and where you will get the minimum tension? Let me tell you, my dear friends, it is a very simple question. But listen carefully, this particular concept is important for us, my dear friends. Let me tell you. So first, just calculate the value of all the external support reaction by using static equilibrium equation. Just use static equilibrium equation. Okay, guys, to calculate the value of what? Maximum tension and minimum tension. I know the formula, my dear friends. What is the formula for maximum tension and minimum tension? But let me derive it for you guys. Okay. Let us consider this one is equal to how much? W. This is the intensity of UDL, right? And this one is nothing as this one is H. And overall span is L, right? L is the overall span. And which is equal to 100 meter over here. Right? So my dear friends, can I write it? Summation Fy is equal to 0. Yes, sir. So we can write it VA plus VB minus W into L is equal to 0. So can I say that VA plus VB is equal to how much? WL. Yes, sir. This is the first equation. Just take the summation of moment at joint B is equal to 0. Right? So guys, we will get a value of VA into how much? L minus W into L by 2, and it is equal to how much? So it is equal to 0. So my dear friends, what is the value of VA over here? It is very simple. VA is equal to WL by 2. So similarly, from equation first, we can say that VB is also equal to WL by 2. VA is equal to WL by 2 and VB is equal to WL by 2. Now these are the support reaction at A and this one is at B. But we have to find the horizontal reaction also. So how we can find it? You know that, my dear friends, the bending moment anywhere on the cable is equal to how much? It is always equal to 0. And we know that, my dear friends, at the center or at the mid span, the central dip is equal to how much? 8 meter. So let's take this particular point into the consideration, which is our C point. At this particular point, the bending moment is equal to 0. Let's put it. So bending moment at point C is equal to how much? So it is equal to 0. So can I write it, my dear friends? Let us take the left portion. VA into L by 2 minus HA into H. We are considering this particular value. As H. Okay. Minus, can I write it? W into L by 2 into L by 4, it is equal to 0. Yes, sir. We know the value of VA. It is equal to how much? Sir, WL by 2. So just put it, my dear friends. You will get the value of HA and it is nothing as WL square by 8H. This is the value of HA. Similarly, if you use summation Fx is equal to 0, you will get the value of HB, and it is equal to how much? HA, which is equal to WL square by 8H. Okay, sir. Now, my dear friends, just find the resultant reaction at support A, which is nothing as it is the maximum tension. The resultant reaction over here, which is RA, and resultant reaction over here, which is RB, and these are nothing as this is your maximum tension force. Now, my dear friends, let's calculate T max, which occur at the support. Listen carefully. It occur at the support, whether it is RA or whether it is RB. But the condition is both the support at same elevation or same level. Then only we are able to say it RA and RB are equal, and T max it is equal to T max. Right? But let us suppose if one support is at higher level and other support is at lower level. So at higher support, you will get the maximum tension. Okay, guys. So this is nothing as under root of VA square plus HA square, guys. Right? So let's calculate the value of T max quickly. फटाफट देख लेते हैं बच्चों. So it is nothing as VA square. VA square is equal to how much? W L by 2 whole square plus WL square by 8H whole square, guys. Right? This is our T max value. And what is the value of T minimum? It will occur at the center. So my dear friends, T minimum. Till that, my dear friends, just calculate the value of T max and tell me what will be the value. This is your T force, my dear friends, which is nothing as T minimum, which occur at the midspan, right? And this one is H, and you know that, my dear friends, this is our HA, and this one is VA. Can I say that, my dear friends, again in this particular portion, summation Fx is equal to 0? Yes, sir. So, my dear friends, can I write it minus of HA plus T minimum? It is equal to how much? 0. So, what is the value of T minimum over here? It is equal to HA. And HA is equal to how much, sir? It is WL square by 8H. Just solve it. You will get the T max and as well as you will get the T minimum. So let's put all the values over here. So let's find first VA and let's find the value of HA. Okay. So let us find, my friends, both the value first. Then we will put all the values in the T max and T minimum equation. Okay, guys. So can I write it? VA is equal to how much, sir? WL by 2. What is the value of W over here? Sir, it is 10. So let's put 10 over here. What is the value of length? Sir, length 100 meter. Sir, 100 meter. 100 divided by 2. How much it is? VA is equal to how much, sir? It is 500. 500 kilonewton. 500 kilonewton. Now, what is the value of HA, my dear friends? HA. It is equal to WL square by 8H, guys. So what is the value of W over here? It is 10, right? L is equal to 100 square divided by 8H. H is equal to how much? Sir, it is 8 meter. So let's put it, guys. So we'll get the value of HA. 10 into 100 square, my dear friends, divided by 64. Simple. So we are getting a value of 1562.5 kilonewton. Now this is VA, this is HA. Just find the value of T max first. Tell me, guys, what is the value of T max? All of you. 500 square plus 1562.5 square. So this is the value of T max, which is 1640.55 kilonewton. And what is the value of T minimum, sir? It is equal to HA, and HA is equal to how much? 1562.5 kilonewton. Just take the ratio of both the values, my dear friends. You will get the value of T max by T minimum, right? We are getting a value of 1.049, which is approximately equal to 1.05, guys. So A is the correct answer. A is the correct answer. A is the correct answer. Understood? Next question in front of you, guys. Next question in front of you. A 3-hinge parabolic arch of span 20 meter and rise is 5 meter. Span is 20 meter, rise is 5 meter. And it is loaded with a uniform distributed load, which is 2 kilonewton per meter. for the whole span. The bending moment at the quarter point is, my dear friends, just tell me the answer quickly, all of you. Tell me the answer quickly, my dear friends. What will be the bending moment at the quarter point? D. Definitely, sir, it is 0. My dear friends, in your examination, they will try to make you confused by putting such type of problem, right? And you know that, my dear friends, it is always 0. Whenever you have a arch, which is to be like this. So, my dear friends, and let us suppose it is a 3-hinge arch. Listen carefully. Let us suppose it is a 3-hinge arch, and UDL is placed over the entire span, right? So in case of 3-hinge parabolic arch, listen carefully, in case of 3-hinge parabolic arch, my dear friends, the bending moment is always 0 at anywhere on the arch, my dear friends, right? So D is the correct answer for this particular question. You can solve it or you can find it. Just you have to write VA is equal to WL by 2, and what is the value of HA? HA is equal to WL square by 8H, right? So just calculate the bending moment at any section, my dear friends, which is present at a distance of x, and rises y, and just put the value of y is equal to 4hx into L minus x divided by L square, right? And just find the bending moment over here in terms of x, you will get 0, right? So D is the correct answer. Remember this one. Next question in front of you guys. The shape of cable under UDL load over the length of cable. Tell me guys, what will be the answer of this one? The shape of cable under UDL load over the length of cable. Tell me guys, what will be the answer of this question? A. Catenary. Very good. Catenary. बहुत ही बढ़िया बच्चों. Very good. My dear friends, let us suppose this is our UDL which is placed over the span length, right? And this is our UDL which is placed over the length of cable, right? Both the cases are different, my dear friends. You can see here, this one is what? Span. This one is span. And this one is what? Length of cable. Now, you know that, my dear friends, if you are wearing a gold chain, or if you know, my dear friends, let us suppose this is a cable, right? If I hold this particular cable only from 2 points, so it will try to make a shape due to self weight, right? Which is acting over the length of cable as a UDL. So that particular condition will make the shape of this cable as a catenary, right? And for this particular condition, it is parabolic, right? But as per our question, the answer is A, catenary. A is the correct answer, not the parabolic. Next question, which is MSQ type problem, guys, right? Listen carefully. In a 2-hinge parabolic arch, let us suppose this is our 2-hinge parabolic arch. You have to take the multiple answer over here, my dear friends. This is hinge and this one is also hinge. Okay, sir. And one internal hinge is over there, my dear friends. Okay, sir. Oh, sorry. It is 2-hinge, na? So let's make 2-hinge. Okay, not 3-hinge. Okay, sir. And let us consider this is our rise as H. And this is our span, which is L. Now, my dear friends, what is the question over here? If, listen carefully, if an increase in temperature will occur, so it will decrease the horizontal thrust. So we have to understand it by deriving the equation. It is very, very simple. Let us suppose, my dear friends, this particular support is free to move. Okay, let us consider this is A, this one is B. Now let us consider this particular support is free to move. So let's make it roller. Okay, sir. Roller. Now, if you increase the temperature of this particular two-hinge arch, what will happen? It will try to elongate. It will try to elongate and it will deflect in this manner. Okay, sir. Now, my dear friends, your roller support will achieve a new position, which is our B dash. Okay, sir. Now, what is the displacement between B and B dash? It is nothing as, my dear friends, it is the change in length or change in span length, delta L. And delta is equal to how much? L alpha delta T, right? If you increase the temperature, so it is equal to L alpha delta T. Now, my dear friends, you know that if I apply a force over here, if I apply a force over here to make this particular displacement as 0, or to make this B dash point as your B point, so how much force is to be required? We have to calculate it. Okay, let us consider this one is F, or let me write it H. Let me write it H. This one is nothing as horizontal thrust or horizontal reaction at B dash or B due to increase in temperature. So can I say that, my friends, just we have to calculate the bending moment anywhere on the arch first. Okay, let's calculate it. It is very easy. Let us take a distance of x, guys. Let us take a distance of x at which the rise is y. Just calculate the bending moment over here, my dear friends. It is very simple. You know that there is no vertical reaction over here, my dear friends. Why? Because we are just considering about the increase in temperature. In this particular question, they have not mentioned you have to consider whether vertical reaction or not. They are just asking about the horizontal thrust. So, my dear friends, generally we avoid the self weight of arch in our analysis, right? So that's why we are able to say that VA and VB is not there, only H is there. So can I say that, my friends, what is the bending moment over here? It is minus of H into Y. Why it is so? Because it is causing a hogging moment at this particular section, which is H into Y. Okay, sir. Now you know that, my friends, how to write the total strain energy. So total strain energy is equal to integration of minus HY square, which is M square into dy divided by what? 2EI. Yes? Okay, sir. Now, my dear friends, as per Castigliano's second theorem, listen carefully. As per our Castigliano's second theorem, if you take the first partial derivative of total strain energy with respect to force, then you will get the displacement in the direction of force. Okay, sir. So let's take the derivative of this one. So total strain energy with respect to H. So what we will get? We will get change in length, which is your change in length of span. That is your delta L. So my dear friends, let's solve it. फटाफट solve कर लेते हैं. So we will get, my dear friends, twice of H into Y square dy divided by 2EI. Now just cancel 2 to 2, and my dear friends, you know the value of delta L, which is L alpha delta T. So my dear friends, can I write it? H is equal to how much? It is equal to L alpha delta T divided by integration of y square dy by EI. Now tell me, guys, if you increase the temperature, then your horizontal thrust, which is acting in this direction, generally it will get increase or it will get decrease. Tell me, guys, all of you. Just tell me whether this particular value will increase or decrease. Okay. Suman says, sir, AD होगा, Raghavendra ABD होगा, Jayesh AND होगा. It is increasing. It is not decrease, my friends. It is increasing, right? You can see here, if you apply the load, which is acting in downward direction, then definitely you will get the horizontal thrust in this direction. And if you increase the temperature, because it is mentioned over here, you have to increase the temperature. Do not decrease the temperature. If we increase the temperature, then definitely this horizontal thrust will get increased here. Tell me what you have to do. Let me show you. Let us suppose this is our two-hinge arch. Now, my dear friends, let us suppose if you have one load over here. Okay, let us apply a UDL, right? Let us apply a UDL over here. Okay, sir, whose intensity is W. Now tell me, guys, this particular reaction, which is your HB, and it is equal to how much? So WL square by 8H. WL square by 8H, and this one is VB, which is equal to WL by 2, and this one is also WL by 2, and this one is equal to HB, and it is equal to WL square by 8H. Now tell me guys, if you apply the load which is acting downward, then you have to apply the horizontal thrust in this direction, right? So similarly, if you increase the temperature, then again you have to apply the horizontal thrust in this direction. So the value is this one, which is positive, and definitely my friends, if you increase the temperature, then horizontal thrust will increase. Okay sir. Now first statement galat hai, so let's check second one my friends. An increase in temperature will increase the bending moment. An increase in temperature increase the bending moment. Listen carefully. It decrease the bending moment. It decrease the bending moment. Why it is so? Why it is so guys? Listen carefully. You know that, let us suppose this is our arch. This is our arch. It will decrease the bending moment, my dear friends, not increase. Let me show you. You know that, my dear friends, this is our rise, which is H, and this one is our span, which is L. You know that this is VA and this one is HA. Let us consider this is H net. Okay, and H net is equal to how much, sir? It is equal to HA plus H, right? So my dear friends, if you want to find the value of bending moment at this particular location, let us consider which is XX. So we have to consider this particular distance, which is X, and this one is Y. Now tell me guys, can I write it MXX, or we can write M arch moment is equal to how much? VA into X minus H net into Y. Now tell me guys, if this particular value is increasing, so your bending moment is decreasing or increasing? Tell me. If your H net is increasing, then overall bending moment of arch will get decrease, right? So my dear friends, B is also wrong. B is also wrong. And the next condition says, if the UDL is placed over the entire span of arch, then it will give zero bending moment anywhere of the span. Yes, it is also correct, my dear friends, for two-hinge arch also, right? For two-hinge arch, my dear friends, the reaction will remain same, like WL square by 8H, WL by 2, WL by 2, WL square by 8H. If you find the bending moment anywhere on the section of two-hinge arch, then definitely you will get the zero bending moment. So again, this particular statement is true. So only C and D are correct. C and D are correct. Okay. Okay, my dear friends. Okay. Next question in front of you guys. Next question in front of you. An isolated load is acting at a distance A from the left hand support, okay, of a three-hinge arch of span 2L, and the central rise is H. The horizontal reaction at the support. It is a very simple question. Just solve it guys quickly. This is our three-hinge arch. Yes, sir. This is our three-hinge arch. And the central rise is H. Central rise is H. Okay, sir. And span is L. And my dear friends, if a W load is acting at a distance of A from the left support, it means this one, right? So what we have to find? We have to find the horizontal reaction. Okay, sir. Let's consider this is A, this C, this is B. So my dear friends, this one is what? VA. This one is what? HA. And this one is what? VB. And this one is HB, guys. Right? So my dear friends, what we have to find? We have to just find the horizontal reaction. And it is very, very simple. Just calculate the value of VA first. So can I write it, my dear friends? Or just calculate the value of VB directly. Just calculate the value of VB directly, right? So my dear friends, this is our distance, which is L minus A, sir. Which is L minus A. So can I say that, my dear friends, the summation moment at A is equal to 0? Yes, sir. So can I write it minus of VB into L plus W into A is equal to how much? 0, right? So VB is equal to how much, sir? It is WL divided by W into A by L. क्या यार? हाँ, This is your VB value. Now tell me guys, if you want to find the value of HB, which is your horizontal reaction at the support, anywhere, like A or like B. So my dear friends, we have to take the summation of moment at C is equal to 0, or you can put in this manner also, moment at C is equal to 0, right? Yes, sir. Moment at C is equal to 0. So can I write it VB into how much? Sir, it is L by 2. VB, which is in anti-clockwise direction. HB, it is in clockwise direction. So plus HB into H, and it is equal to 0. So my dear friends, HB is equal to VB into L divided by 2H. Okay, sir. What is the value of VB? Just put it, guys. Just put it. WA by L multiplied by L by 2H. Just cancel this one. So you will get WA by 2H. I will tell you, no problem, I will tell you, no problem. Now, in this question, the span is 2L. In this question, the span is what? 2L. Okay, sir. The span is 2L. So let's check it, my dear friends. Let's check it. If you put 2L over here, 2L minus A, if you put 2L over here, so you will get WA by 2L. Okay, sir. Now, my dear friends, if you put 2L over here, so this particular value is equal to how much, sir? It is equal to L. Let me show you. L. Okay, sir. So what we will get over here? It is equal to VBL by H. Okay, sir. VBL by H. This is our HB value. This is our HB value. Okay, sir. Okay, sir. Okay, sir. And what is the value of VB? So VB is equal to WA by 2L. And let me edit it again. L by H. Okay, just cancel it. Again, you will get WA by 2H. Again, you will get WA by 2H. The same value is there, my dear friends. The same value is there. If you put L, if you put 2L, the same value you will get, my dear friends. Why it is happening? Because your length of span will get cancelled. Understood? Tell me, guys. Tell me, my dear friends, tell me. If you put 2L, then what you will get, my dear friends? The same value is there? Okay, sir. You can put 2L, my dear friends, no problem. Definitely you have to put the 2L, but you will get the same value. Okay? Okay, sir. So what will be the answer? B is the correct answer over here. B is the correct answer. All of you are able to understand or not? This one. All of you, tell me, guys. Okay. ठीक है. So my dear friends, this is all about for today, my dear friends. And if you want to join my different session, like your interactive session and like quiz session, then definitely you can have to follow me on Gradeup. And my dear friends, definitely you will enjoy that particular session, because we are discussing a designed problem, or like for upcoming problem which may be come in your gate examination, right? You may get the feel of each and every question over there. So just you have to follow me on Gradeup by using the link below, which is already present in the description box. Okay, so just follow me on Gradeup, my friends. Definitely you will enjoy it. So tomorrow, my friends, at 2 p.m. I will be live on Civil Champion. You can join that particular session, right? At Civil Champion. And at 6 p.m, my friends, we will be live on Gradeup app, in which we will discuss the numerical answer type problem, which is a mixed match series, in which I'm discussing about two topics. First one is your RCC and second one is your structure analysis, right? So you can follow me on Gradeup, then you are able to join this type of session also. Okay, so my dear friends, acha. Okay, my dear friends, okay. So this is all about for today, my dear friends. This is all about for today. So if you want to learn more, my dear friends, you have to join Gradeup app. You can watch that particular video, my dear friends, for free of cost, definitely. But if you want to learn the concept in the detailed manner, then you have to join the Gradeup Super. If you are new here over here, my dear friends, then you can understand it. So you can join the Gradeup Super, in which you will get the Gear Up course, Rank Up course, Vision 2022 course. And my dear friends, if you want to join our platform, then you have to contact on this particular number, right? So in Vision 2020 course, you will get 950 plus live hour classes, right? And 10,000 plus practice question, 100 plus mock tests, 120 plus chapter wise study notes, right? It means you will get the PDF of study notes as well as these type of notes which is written in the class itself. Okay. Thank you, Anusha. Thank you, Raghavendra. Kaushalya, thank you. My dear friends, these are our staff faculties who will teach on Gradeup, and they are highly experienced, right? And Gradeup achievers. And my dear friends, there is one important information, you guys. After 10th December, our cost will get increased. So if you want to join our platform, you can join right now and before 10th of December. And my dear friends, if you want to join later on, then definitely you can go it, right? But whenever you will join, my dear friends, for our Gradeup Super, then definitely you will get the unlimited access to all the courses, which is ESC and civil courses, right? And mock test also. Okay, so you will get India best faculty team, complete doubt resolution, full syllabus coverage, as well as you will get a green card, my dear friends, to join your online mock test, which is designed by topper and based on latest pattern of examination, right? So my dear friends, you will get unlimited access to the Gradeup Super if you join Gradeup Super, right? So thank you so much for joining the session, my dear friends, and this is all about for today, and we will meet tomorrow at 2 p.m. on Gradeup Civil Champion YouTube channel. Okay, so till that, bye bye, take care and good night.